Okay, so section 10.3 covers ellipses. Probably something that you didn't take a look at in Algebra 2. Maybe Algebra 2 Excel touches on it. I'm not totally positive on that. But essentially, when we look at an ellipse, it resembles an oval, right? We have a center, we have vertices, and we have foci, all of which are relevant points either within or on the ellipse. All right? We have what's also known as a minor axis and a major axis for each ellipse. The major axis, by definition, is the line through the foci joining the vertices. So in this case, our major axis would be horizontal. So the other way to think about it, it's the longer one, right? So if our ellipse is kind of stretched out vertically, then the major axis would be running vertically. Okay? So, but by definition, the major axis is the line connecting or going through, passing through foci and joining vertices. And I'll say that the minor axis, as a general definition, is perpendicular to the major, and it's always going through the center. So in this case, our major is right there, because these are the foci and the vertices would be here. Okay. So the center, of course, by obvious definition of a center, right, is equidistant from its vertices and then separately equidistant from its foci. So the vertices are A units away, and in this case, left and right. Foci are C units away, again, in this case, left or right. They could be vertically A or C units away as well, and we'll look at the difference. Because of the way that these values are generated and the fact that the distance from the foci to kind of like a vertice, quote unquote, of the minor axis creates this triangle here, and they are going to be isosceles because those distances from the foci to point B would be the same. We would then be able to use this relationship to figure out the entire distance of the major axis. Everything about an ellipse stems from this idea of really Pythagorean theorem and then coming up with what the function of that ellipse would be. So we have these distances, A plus C, and we have an A minus C over here, the distance between them. And if we add those up, because the C's end up canceling out, the whole thing is 2A. And then that whole thing of 2A is equivalent to, using Pythagorean, more of the proof is in the book, but it would be equal to 2 times the square root of B squared plus C squared. So then we get to the point where, right, of course we have A is equal to the square root of B squared plus C squared. A squared is equal to B squared plus C squared. It's all coming back to that Pythagorean theorem there. And C, which is the one that we typically need to solve for, C squared, or C would be equal to the square root of A squared minus B squared. So key values, we already see where A and C come up in our vertices and foci, but C will not be in the equation for an ellipse. A and B are going to be there. Sometimes you have to extract them and find them, but A and B are in the standard form for an ellipse. and we'll be solving for C to figure out where those foci are. And the connection between the A, the B, and the C are going to be Pythagorean theorem. Okay? So here are your standard forms. The first one, the major axis is horizontal, and the second one, the major axis is vertical. Now the difference that you're going to look out for, notice that with all of the standards, your A and your B are positive, they're greater than 0, but A is going to be larger than B. Okay? So based on that, if A is the largest number, notice that A is under the X. A is under the X. The A value gets added to the X coordinate, which stretches out where your vertices and or foci will be, making the horizontal distance larger. Right? So wherever the larger denominator is, that's where your major axis is going to be. Right? So I'll just write that in very simple form there. Larger denominator yields major axis. So, and based on this inequality, this has to be true. A is bigger than B. So therefore, when our major axis is vertical, A, which is the larger one, is under the Y. That's telling me to add A values to the Y coordinate of your center, and then that's going to stretch out your vertical.
If it's like a larger denominator, wouldn't it be like a smaller?
Yes, I totally agree with you, and that's like when I was first reading this. So in case you couldn't hear at home, Akshay's saying, well, if it's a larger denominator, doesn't make that overall part of the that part of the equation, the fraction, smaller, for sure. But the relationship between how you add and subtract the A and the B to get to your vertices, the outside points, and I think that the best way to kind of prove it to yourself, to everybody, is to use a table of values and see how that ends up working out. But essentially, by the rule, we're taking these A's and these B's and adding them to either the X or the Y coordinate of the center, and then we're finding those points. So if the A is larger and it's getting added to the X, then we're stretching horizontally and compressing vertically. And if the A is larger and it's getting added to the Y, we're stretching vertically when we're moving away from our center. The ones at the bottom are just centered at the origin, so it's the same thing happening, but we don't have an H or a K in there. Other important thing to note is it's always equal to 1. So we have to force that, right? Sometimes we're going to be completing the square and making sure that we set the standard form equal to 1. So let's take a look. Answers are here. We'll look at those in a moment and compare, of course. So it's okay, just a quick glance at how the answers are. It's okay to have them written as a 25 and a 16. You can also keep it written as a 5 squared and a 4 squared, and then you can clearly see the A and the B. Okay? But you don't. Both are acceptable. Is all that I want to point out there. So first example on the left-hand side there. Find the standard form of the equation of an ellipse having foci at negative 2, 2 and 4, 2, and a major axis of length 10. Okay. So, first observation you want to make is what variable changes? The x or the y? To go from the center or from the foci, from one foci to the other, because we don't really have the center at the moment. Which variable is changing?
The x.
The x. So that means our foci are separated like this, And by definition, our center is in the middle of those two, okay? So all I'm doing is I'm making a general observation that my major axis will be horizontal here, okay? So let me highlight that real quick. So -2 and 4, that's what's telling me that my major axis is horizontal. The longer axis is horizontal, okay? From there, I want to figure out what my center is, right? I want to say, because that's my h and that's my k, that's a big part of what my standard form is. So again, by definition, the foci are equidistant from your center. So I can find the average of those x coordinates, right? So my center, the h coordinate of my center would be the -2 plus the 4 divided by 2. So you get 1. Therefore, my center is at 1, 2. That is my h, that is my k. Okay? The other thing that I'm told in this problem is that the major axis has a length of 10. And in the standard form, in the notes in the beginning, they're saying the distance from all the way across on the major axis is always 2 a's. So you take 2a, you set it equal to 10. So a is equal to 5 based on that. That's always how it's going to work. And that's stemming from the Pythagorean theorem and the fact that the foci have the same value from the minor axis vertice, quote unquote. It's not really a vertice, but. Okay. So now we have an A. What else do we have? Let me ask it like this. Let's fill in what we know. We know we have an h, right? So we know we have an x minus 1. We know we have a k. We have an x minus 2. I'm sorry, a y minus 2. Right? It's going to equal 1, so we're going to get there. We need an a squared and a b squared, right? What do we know so far? We know the a squared. So we know 5 squared can go there. We need a b squared. Bring it back to Pythagorean theorem. So we still, in order to find the b squared, we need to also have a c squared. Do we have information about the c? Go back to the beginning, the notes. What does c stand for?
B squared minus b squared
Yes, sure.
equals c squared.
But like in terms of an ellipse, what is the c? Yeah, the distance from the center to the foci. So we started with our foci, we averaged them to figure out where the center is. Well, how far apart now is the center to one foci? 3. So our c value is 3. C equals 3, which is the distance from center to foci, either one, right? Plus and minus 3 we go. So the c is 3. So we know 5 squared plus the b squared is what we don't know, is equal to the 3 squared, right? So therefore, b would be equal to the square root of oh, this should have been a minus in between. Come on, erase. B would be equal to 5 squared minus square root of 5 squared minus 3 squared. That's what I want to go back to and double check. B is equal, so let me just finish this real quick. B is equal to 4. So here we find that our B is 4. So the last part that we have to put into our standard form is this 4 going right there. So we would have x minus 1 squared over 5 squared or 25, either way is fine, plus y minus 2 squared over 16 is equal to 1. Okay. All right, the second example here is saying sketch the graph of the given, what appears to be, looks just like a polynomial with x's and y's put together, right? It's not in any standard form quite yet, so we need to get it there. So we have 9x squared plus 4y squared plus 36x minus 8y plus 4. So our job is to complete both squares. We want to put our x terms together and we want to put our y terms together. Okay? So I'll first do some of that work up top and then we'll look at graphing it. Or I'll put it to the side, I guess. I should have enough room here. There we go. So first off, start by saying, well, 9x squared plus 36x plus something, right? I like to put a box there, plus 4y squared minus 8y plus something equals, get that 4 out of there, equals negative 4. Okay? The other thing we have to get out of there is when we complete the square, our a needs to be a 1. So we're going to factor the 9 out, we're going to factor the 4 out from each of them. So 9 times quantity x squared plus 4x plus what? What do we put in those parentheses to complete the x one? 4. Good. But we're thinking, what are we actually adding to that side right now? 36. Good. Keep that in your mind. Okay, so then we have plus. If I take the 4 out here, y squared minus 2y plus what? 1 equals. So now I have a negative 4. Right, I actually added a 36 and a 4. Does that make sense to everybody? People at home, I guess just speak up if it doesn't make sense, because I don't see you guys when I have the screen shared like this. So head nodding and stuff isn't totally helpful. Okay, so simplify, right? And write it as a perfect square. So 9 times x plus 2 squared plus 4 times y minus 1 squared equals 36. Divide by 36, so we make it a 1 over there. All right. So this one works out nicely because 9/36 and 4/36 fully simplified, having only a denominator. So we have x plus 2 squared. 9/36 would be a 4th, so I can think of that as a 2 squared. And y minus 1 over 3 squared equals 1. So now that I see where the larger one is, right, it's under the y, that means I'm going to have a major axis running vertically. So that means my center, based on my h comma k, is -2, +1, and I'm stretching it out 3 units up and down to get those coordinates. So plot the center first. X plus 2, y minus 1, right? Yeah, sketched it wrong at home, that's fine. So -2, +1, that is correct right there. Right, with a vertex or vertice moving up 3 and down 3 from the y. So -2, comma 4, -2, comma -2. and we can get the points that would run on the minor axis by adding and subtracting 2. So we can shift to here, to here. So this problem, it just said graph it. You don't have to get any more than that. The next one, and many of them will say, what are the foci? Right? So then I would then take my A and my B, figure out what my C is, and then I could also plot my foci. But this is the graph. It's pretty basic. Questions on those two? At the end of class, I want to revisit this proof of where does the a squared minus b squared come from, okay? I want to do it start to finish instead of how it was halfway presented. Okay, next example. Now this one says find the center, vertices, and foci of 16x squared plus 25y squared minus 32x minus 50y plus 16 equals 0. Okay, so all of the answers are over there. We'll get to that, obviously. Same process, except it's not asking us to graph it, but it is asking us for the foci. So that's one extra step there. It's a little bit more tricky, but same idea. We have to complete both squares, okay? And then we have to find our key values are A, B, and C, ultimately, in this one. Okay. So group your X's. And your Y's. Get that constant out of there. And then figure out what values you need to add to both sides to complete your squares. So again, you're factoring out the a that's there to begin with. So we have an x squared minus a 2x. So we need to add a 1. Factor out the 25. So we're adding another 1. Okay. Except for we're not really adding 1s, right? Because we have a factor out in front. So we are adding a 16 and a 25. So we already had a negative 16 over there, so those will cancel. We'll be left with a 25 as our constant on the right-hand side. So now I take a moment and I write this as a square, right? So x minus 1 quantity squared times the 16 plus 25 times y minus 1 squared equals 25, I'm sorry. Now I have to make it 1, so I have to divide by 25. That's a key part. The right-hand side has to equal 1. So on the first one, I have 16/25. I want to write that completely in the denominator, even though it's not super pretty, but that way I can identify what my constant is down there. So 16/25 written as just a true division would be written as dividing by 25/16, right? So let me put that there. The other one goes to a 1, which is great. I'll put it as a 1 so we can identify it more easily. And the one more thing that I want to do is, right, 1 is obviously the same as 1 squared. But 25/16 we could write that as 5/4 quantity squared, right? And that's helpful because now we know what our A is, it's larger, and what our B is, smaller. So that means that our major axis is running horizontally because I will be adding and subtracting a larger value to my x coordinate of my center than I would to my y coordinate of my center. So my center, as we can see, it's written down for us already, 1, 1, my each comma k. My vertices, if I add and subtract 5/4 to the x coordinate, that brings me to 9/4 would be in the positive direction, comma 1. Negative 1/4, comma 1 would be in the negative direction. Okay, so the center and the vertices are accurate to what we have going on. So our major axis, I like to always kind of consciously think about that, is horizontal. In order to get the foci, I need to know what my C is, right? I've got my A, I've got my B, I need my C. So C is equal to the square root of A squared minus B squared. So C is equal to the square root of 25/16 minus 1. So 25/16 minus 16/16 would be 9/16, or square root of 9/16, which is 3/4. So then once I know what my C is, remember that my foci are equidistant from the center, C units away. So then I would add and subtract 3/4 to the x coordinate, and that gives me the foci of 7/4, comma 1, and 1/4, comma 1.